All right, guys. Today we are going to talk about a new form. So we're still going to be talking about parabolas, but we're going to be talking about a different way that we'll see the equation. We're going to be talking about vertex form. All right. So it's right there in the name in terms of what we're going to be looking for. So what we can see is here is the standard form. Here's the vertex form. Let's think about what has changed and what has stayed the same. We still have an a value. That means the same thing. Right? It's the leading coefficient, and it determines if I'm going to open up like this, if it's a positive, or if I'll be concave down, if it's a negative. But what's different is instead of having to do negative b over 2a to find the vertex and the axis of symmetry, instead, the axis of symmetry is this number right here, the h value, and then k, this standard, or this constant term rather, is going to be the y value of the vertex. Okay, so let's look at this example, and I want to talk about why it works, why this works. Okay, if we take a look at this equation here, negative x minus 2 squared plus 5. Let's think about what it means to be a parabola, what it means to have an axis of symmetry, what it means to be a vertex. To be a parabola, you have all these points that have a perfect mirrored point that's the same distance away from the axis of symmetry. The axis of symmetry splits the parabola into these two mirror images, and the vertex is the only point that doesn't have a partner. Okay, it's the only point that doesn't have a partner. So to not have a partner, think about what that would imply, right? It implies that whatever I plug in here for x, I get a unique result because of that. The only way that could happen, is if this right here, what's in the parentheses, becomes a 0. Because 0 squared versus negative 0 squared, there's no such thing as positive or negative 0. So it doesn't matter. So that's what I'm seeking out. So if I think about setting it up like the XY chart that we've been doing with standard form, right, where we say, okay, I'm looking to track my inputs and my outputs. And we put the vertex like in the middle. Right? Well, I know that guess what I want to put in the middle? 2. I guarantee you that. I guarantee you that. Right? When I plug in 2, 2 minus 2 is 0, 0 squared is 0, negative 0 doesn't matter, plus 5, 5. I promise you, when we move in the next directions, so 3 and 1, this is what I mean when I say the 2, because I get the 0 in here, and 0 squared is unique. This is where, if I do 1 minus 2, okay, 1 minus 2 squared, well, what's 1 minus 2? It's negative 1. What's 3 minus 2? It's positive 1. And is there actually a difference between negative 1 squared and 1 squared? No, they both become 1. Then I take the negative version of that, and then I add 5. So I get 4 either way. So that's why this formula works and is useful, is that when you see something like this, the x that you would plug in to turn this into a 0, that's the vertex. It has to be, because that's the only unique output, or like it's the only thing that is a unique input that will allow you to square this and have there be no difference. Like with 1 and 3, they're different inputs that get me the same result when I square it. Right? Whereas 2 is a unique situation because it results in a 0 squared, and there's no such thing as a difference between positive or negative 0. There's only 0. Whereas here, 1 minus 2 is negative 1, 3 minus 2 is 1, but because I'm squaring it, there's actually, they become the mirrors of each other. Okay, so that's like the why it works. All right, so a little step by step, right? Plot the vertex, draw the axis of symmetry right through it, and then just start adding 1 to either side. Just start moving out the same way we did with these other equations. So let's take a look at what this would look like. All right. I picked this example because you want to be careful and remember that the actual standard form is x minus h plus k. So if I'm subtracting the h, right, then the actual h here is -1. And if that's confusing to you, I'd say the best way to think about it is, I mean, like I said, instead of worrying about the actual form, think about the why it works, which is if I do, 1 plus 1, I get 2, and 2 squared is 4. But I could also do -3 plus 1 and get -2, and -2 squared is 4. So what I'm looking for is the input that makes this unique. And the only way it can be unique is if it's 0. So what is the input that makes it 0? -1. Because -1 will result in 0 squared minus 3, which is -3. So -1, -3. That's my vertex. And if that's my vertex, well, then I also just found my axis of symmetry, right? It would have to be going up this line here, -1. So now let's go find other points, right? Like I could move towards, sorry, yeah, right, let me go this way, 0 and 1. Or I can move my way towards -2 and -3. I'm going to go with working my way towards 0 and 1. Now in the other problems, 0, right? I mean, 0 is still guaranteed to be a y-intercept, right? Because I'm going to be x of 0. But it's not guaranteed to just be this right here, okay? Because watch what happens. 0 plus 1 squared. 0 plus 1 is 1. 1 squared is 1. 1 minus 3 is -2, right? So it's still the y-intercept, but it's not like in standard form that this at the end just is the y-intercept. It's not like that with these problems. 0, -2. I would say that's something people get confused a decent amount. All right, now let's do 1. 1 plus 1 is 2. 2 squared is 4. 4 minus 3 is 1. So 1, 1. Right. -2 is going to be a mirror of this one. It has to be. And -3 is going to be a mirror of the other one. It has to be. So -2, -2, and -3, 1. And look at that. I've got my parabola. Right? So same shape, right? Same result. We're just looking at it in a different way. Right? It gives us different pieces of relevant information. Okay? Right? So I have one here that I would like you guys to try on your own. Okay? And then there's 2 for the homework. Okay? So what I'll say is I'll end the video now and try and keep it short. All right? If you're in a hybrid class, then you'll just watch this today instead of having my lesson about it, but I'm going to go over basically the same amount of stuff. All right? So good luck on the homework. We'll go over those problems. I'll probably make a video about the homework problems over the weekend. All right?